Okay, good morning. This is Professor David J. De Los Reyes. Okay. My topic for this session, this will be a continuation of my AC machines, long video format discussion. And we are now on lesson number 33. Okay, let's proceed. The subject matter for this morning, it's October 7, 2023. The title of the topic of the subject matter will be Alternating Current Machines, lesson number 33. And the title of the topic will be Polarity and Connection of Three-Phase Transformers. So we are done with single-phase transformers, okay? But before we will discuss the connection of a three-phase transformer, how come it is called three-phase, okay, which is different from the single phase. Let's try to bring out first the polarity connections of three-phase transformers. The connection for additive polarity for three-phase. This is number 3 with symbol like that, meaning this is phase. Okay? 3 phase. Or in short, it's just simply like that. Okay? 3 phase. This is termed to as 3 phase. Right? If I put number 1 here with the symbol like that, it's single phase. Right? Single phase. Number 1 with a symbol like this, single phase, this is 3 phase. Okay? The additive polarity for three-phase transformers, three-phase. This is three-phase. The markings will be like this. For the primary side, of course, three-phase, we are now given 3 lines. 3 lines. Okay, we are given 3 lines. 3 lines on the primary, 3 lines on the secondary. Okay. Let's continue. The markings on the primary side, it's designated by capital letter H. High side, high side, high side, meaning high side with subscript 1, meaning line number 1 on the high side, line number 2 on the high side, line number 3 on the high side. For the polarity to be additive, okay, we interchange the connection on the secondary. We alternately place H3 instead of 3, it should be 1. For 2, okay, it should be 2. Okay, and for H1, it should be 3. So this is 1, 2, 3. This is 3, 2, 1. So if we try to connect the terminals H1 and H3, if this is plus and this is minus, and if we try to interconnect it, okay, if we try to use the voltmeter, okay, what will come out will be the sum of the value on the primary side plus the value on the secondary side for it to be additive. Right? For the subtractive polarity, the markings on the primary will still be the same. We did not change. High side number 1, high side number 2, high side number 3. For the secondary side, okay, 1 and 1, this is 2 and 2, and this is 3 and 3. Right? So if 1 is plus, and 1 also is a plus, if we try to connect this terminal here with this, then we try to get the voltmeter reading, okay, what will come out, they will subtract each other, right? Because this is plus and is plus. They will subtract. Whichever is bigger, that will be the remaining voltage that will come out on the voltmeter. So for the subtractive polarity, H1 and X1, H2 and X2, and X3 and X3. Okay? It's almost similar to the single phase. Okay? Let's try to go to the connections for three-phase transformers. We are now going to discuss three-phase transformers. Three-phase. What's the difference between three-phase and single-phase? Single-phase transformer will just be sampling like this. Okay, that's single phase. But for three phase, we add two more. We got okay, even on the secondary side. Okay, so for a three phase, it's like this. So it's more complicated. For it to be three phase, there should be three single phase windings on the primary and three single phase windings on the secondary. For the connection now, it depends on what will be the connection that will be made. It depends on the application. Okay, if you want the connection on the primary to be Y, okay, you try to interconnect these three here as like this. You got it? And if you want the connection on the secondary side to be delta, okay, you interconnect these three single phase windings so that the connection will be something like this. Okay, so at least you now know what's the difference of a Y and a delta. A Y resembles a letter Y, that's why it's Y connection, right? Letter Y. Right? And for a delta, it is something like this. So for a Y, there are three windings like this. Okay, for a delta, there are three windings also. Then you try to bring out the three lines. Okay? You got it? That's why for a three phase, there are always three lines on the output terminals. But for a Y connection, there's a problem a little bit with that one because we get a common point at the middle, and sometimes they bring out the port line and they term that one as the neutral line. Live 1 number 2, live 1 number 2, live line number 3. So for a Y, there's a port wire and we call that one the so-called neutral line. For a delta, there is no port line. It's just three lines, right? Live 1, number 2, 1, number 2, and number 3. Okay? Okay, I will try to erase this one so it will look good. So at least we now know how come we brought out or we bring out a three phase. Three phase is actually an interconnection of three single phase transformers. Okay? So the origin of this three phase actually it originates from the so-called single phase. There will be three single phase transformers which are interconnected. Okay? After the interconnection, we called it a three phase already. So that's the difference between a single phase and a three phase. Okay? Okay, I will try to remove this one. Okay, so it looks good again. Right? Okay. Oh, it should be green. Okay. Oh, so at least we now know how come we arrived at three phase. Three phase transformers, I will repeat it, it is just an interconnection of three single phase transformers. And for the connection, it could be a Y connection or a delta connection. So the next time around, we will be discussing the interconnections of transformers depending on the application. If it is a step-down transformer, what will be the correct connection? Will it be Y or delta? If it is a step-up transformer, what will be the good connection? Will it be Y or delta? So the next time around, we will be studying the different application of the connection of transformers to arrive at the proper, what you call this, purpose. Step up, will it be Y or delta? Step down, will it be delta or Y? The next time around, we will discuss that one. Okay, let's try to bring out the voltages, or just a preview, okay, for a three-phase transformers. For a single-phase transformer, the output will just be something like this, right? Single phase, that's only winding. But for a three-phase, there will be two additional wave that will come out because it's three-phase. This is only for one phase, right? The next phase might be something like this. And the next phase will be like this. Okay? So this is the first phase. This maximum here. Single phase, first single phase, second single phase, next single phase. So these three single phases is termed to as three phase. So in one, what you call this, in one cycle, there will be three graphs that will be coming like that with the what you call this, the origin of the voltages that will be coming out are not actually the same. The first one is that it will start at 0. Am I still at camera? The first one will start at 0. The next one will start at 120 degrees. And the next one will start at 120 plus 1. This is 240, right? So actually, if we try to bring out the angle of the voltages, okay, the first one is at 0 degree, the next one will be at 120 degrees, okay? There's a lag time, right? They will not try to come out at the same time. There's a lag behind of around 120 degrees. And the third one will be negative 120 degrees. So if we try to bring out the so-called, it will be something like this. This is for the first phase, this is for the second phase, this is for the third phase. Okay? The, what you call this, the coming out of the voltages as they were induced on the windings, they will not try to occur at the same time. There is a lag behind of around 120 degrees. Okay? So it's like this. It's just like the graph of this, what you call this, satellite orbiting our Earth. Okay? This is the induced voltage from the first winding. This is the induced voltage from the second winding. And this is the third induced voltage from the third winding. And this is termed to as three-phase. Okay? So there are three variations on how the voltages will come out. The first one will start at 0. The next one will start at 120. And the third one will start at around 240. So actually, if we try to use this one in the so-called rectification, okay, in the rectification of direct current of alternating current voltages, for a three-phase, the output will be smoother, you know. Okay, for a three-phase. But for a single phase, it's just alone, you know. It's just one like that. So, I mean, if you try to rectify it, it's much more rougher than for a three-phase. So, actually, three-phase is good for rectifying what you call this voltages, right? Because the graph of the output induced voltages will be smooth, you know. See? It's not yet rectified, but it's already smoothing out, right? So for three-phase voltages, this is good for rectifying direct current. Okay? But most of the time, the application of this is actually for the so-called power distribution. It is for the distribution of power to household chores or business entities or big companies, something like that. I am just telling you that the graph of a three-phase voltages is much smoother, you know. Okay, at least we now know, this is just a preview, right? So at least we now know how come we arrive at a three-phase transformer. Three-phase transformer are actually just the interconnection of three single-phase transformers, okay? They are just simply interconnected, whether it will be Y or delta. And for the coming out of the voltage that will be induced on the windings, it will be something like this. There is a voltage, what they call this angle of lag for each voltage, right? First phase, it will start at 0. Okay, second phase, it will start at 120. The third phase will start at 240. Okay? So actually, if you try to take the graph of the output of the windings, it will be like this. Okay, it's smooth. So if you try to rectify this one by using a rectifier circuit, of course, this is almost rectified, or it's not rectified, but the ripple is smaller, right? You know, for a three phase. For a single phase, maybe the ripple is big, but for a three phase, once you rectify it, it's easy to rectify this one because it is much smoother. Okay, that's it, guys. That this is just the preview of the study by so-called three-phase transformer. Okay, good morning from Los Angeles. This is Professor David J. Tilofre.